Good morning, children. Welcome to your chemistry online class. Last class we have discussed about different types of redox reactions. And this is our last topic, that is balancing redox equations. All other topics are deleted from this chapter. So we'll see how to balance a redox equation. I know from lower classes we are studying the balancing of equations. We'll see how to balance redox equations. We know redox reaction is the reaction in which oxidation and reduction are conducted simultaneously. So we'll see how to balance redox equations. So we'll see the steps. There are mainly two types. We are seeing a half reaction method and oxidation method. Half reaction method is also known as ion electron method. It's having 7 steps. We'll see that. The first step is write the formula equation if it is not given in the problem. Then write the ionic equation. First, if maybe the equation will be, the reaction will be given in a sentence. So we have to convert that sentence into equation and we have to write its ionic form. That is the charges we have to write. The next step is assign oxidation numbers. We know how to assign oxidation number, that we have already studied. And delete substance containing only elements that do not change oxidation state. And we know if an element is in a if elemental form, for example it is N2, it is bearing no charge, such substance we can delete. Then next step is write half reaction of oxidation. How to write the half reaction? For the half reaction, balance the atoms, balance the charge. Write half reaction for reduction. First we have to we know redox reaction is made consists of two reactions, both oxidation and reduction. So first write half reaction of oxidation, that is only oxidation part. Then balance the atoms and balance the charge. The second step is write half reaction for reduction, that is balance the atom, balance the charge. Same. The next step is conserve charge by adjusting the coefficients in front of the electron so that the numbers lost in oxidation equals the number gained in reduction. So we have to adjust the coefficients. Then only the oxidation and reduction numbers will equal. It will be clear while doing the example. The next step is combine the half reactions and cancel out anything common. So then we have to, first we have separated these two and we again we are going to merge these two reactions, and if there are any common elements, for example if there are hydrogen in both equation, we can cancel it. So such things we can do. The last step is combine ions to form the compound shown in original formula equation. So combine and write in a ionic form and check to ensure that all other ions are balanced. So we'll see an example, then it will be very clear. So we know the first step is we'll see the reaction. The reaction is hydrogen sulfide is reacted with HNO3, which gives H2SO4, NO2 and H2O. This is our reaction. What is the first step? First step is write the formula of the equation. So this is our formula. And second step is write the ionic equation. So here we can see HNO3 is in the ionic form. So what will be the ionic form of HNO3? That is H plus and NO3 minus. And H2SO4 will be in 2H plus, SO4 2 minus H2SO4. NO2 and H2O will be like the same. So this is the ionic equation. Then the second step. So first step is write lengths. Second step, assign oxidation number, delete substance containing only elements that do not change any oxidation state. Assign the oxidation number. So we know the oxidation number of hydrogen plus 1 So then if we calculate, there are 2 hydrogens, so plus 2, so sulfur should be minus 2 to cancel it to each other, will get 0. So I know how to identify, I hope you know how to identify oxidation number, that we have already discussed. So identify the oxidation number, assign the oxidation number, and cancel the compounds which are having only elements that do not change oxidation state. For example, if you check here, plus 1 is changed to, here oxidation of H2 is plus 1, same. So it is having no change. So such things we can delete. Here H plus, only H plus is H plus only, so we can eliminate that. For example, NO3, we'll check with NO3. Nitrogen oxidation here is plus 5. Here it is plus 4. So it is changed. So we have to write that. H2S, we'll check with the sulfur, minus 2 to plus 6. So it is also changed. So H2S we have to write, NO3 we have to write. Then this side also we have to include those things. So we can eliminate H plus and H2O. Okay. So whatever is not changed, that all things we have to write. Other substance we can delete. Then write the half reaction for oxidation. So here if you check the here, sulfide oxidation state minus 2 to plus 6. So it is increasing oxidation number. We know if a substance increase its oxidation state, then it is oxidized. So that is the oxidation reaction. So what is the oxidation reaction? Oxidation reaction is sulfur is being oxidized. So H2S gives SO4 2 minus. This is the our half reaction for oxidation. So balance the atom. First step is balance the atom. How we can balance the atom? So if you check this example, here 2 hydrogens are here, but in this side no hydrogen. So we have to add hydrogen. Okay. Then here sulfur, how many sulfur is there? Only one. It is equal, and oxygen. Here no oxygen here, but 4 oxygens. So we have to balance the atoms. We'll see how to balance. So to balance oxygen, we can add H2O. So for balancing atom, first step we'll add H2O. Okay. So we'll see H2S. We need totally 4 oxygen. So if first we'll check that. Okay, 4 oxygen. If it is need 4 oxygen, it also should have 4 oxygen. So totally how many hydrogen will come then? 4 into 2, 8, 8 into 10. So totally 10 hydrogen should be there. So we have to add 10 hydrogen this side. Like this method we have to balance. I know you already in our 9th or 8th standard we have studied how to balance the equation. So such manner we have to balance. Okay. So this gives 10 extra hydrogen. So 10 H atoms added to right side. In basic solution, OH minus ions and water can be used to balance atoms. So if it is an acidic solution, we have to add H plus to balance, and water, H2O and H plus we can add to balance the equation. Here we know sulfuric acid are not there, so acidic solution. So we have to add H plus and water to balance equation. If it is a base, we have to add OH minus and water. These are the common atoms we can add to balance the equation. The next step is balance the charge. So how we can balance the charge? Here minus 2 to plus 6. Okay. So electrons, we have to add electrons to balance the charges. So if we take left side, here plus 2 is here, plus 2 minus 2 0. Then here minus 2, 4 is there, so minus 8. Then this is also plus 8, so it is 0. In the left side it is 0. We'll see with the right side. Right side it has plus 8 charges. 8 charges is there. So we have to add 8 electrons. So you have to identify oxidation number because minus 2 to plus 6. So it is loss of 8 electrons. So we can add 8 electrons. So the second method is write the half reaction. So we balanced the oxidation state. and oxidation reaction, we will see with the reduction, same step. Here reduction is nitrogen's case, nitrogen reduced to +5. So we'll check with atoms. Okay. First we have to uh, check the here n, how many n's are there? 1. Okay, here 3 oxygen, here 2 oxygen, so we have to add balance it with water and acid. We'll see. Sorry, H plus. So H2 we can add here. 3 oxygen are here. So how we can add 3 oxygen? Here already 2. One more we need. So we can add only one H2O. So we'll check if hydrogen balance. This side no hydrogen, this side 2 hydrogen. So we can add 2 H plus. Very easy. And we'll check with a charge. This side how many charge? +5 -6 +1, then +2 +1 +2 +3 will be there. This side will check charge +4 -4 0. This side it is 0, but this side charge will be there. It will be clear here. So electrons added to the side having greater positive net charge. So left side having +1 charge. So one electron added to wherever is there greater positive charge, that side we have to add electron to neutralize that. So equal. Then conserve charge by adjusting the coefficient in front of the electron so that the number lost in oxidation equal to the number gained in reduction. So write the ratio. So we have seen in the oxidation 8 electrons we have had, 8 electrons lost in the oxidation and only 1 electron gained in the reduction. So we have to balance this also. So here you can see that. So we have to add the ratios in front of the equation. So multiply oxidation reaction by 1 like cross multiplication method. Here 1, here 8. Multiple reduced part with 8. And combine the half reactions. And we can cut the common terms. And finally we can write the equation. This is the so combine. Here you can see 8 electrons. Here also 16H plus is there, 8 electrons is there, we can cancel. 4H2O, 8H2O we can cancel. Similar method, whatever are repeating there we can cancel it. And we can write the equation. The left out reaction 18O3 H2S 6 plus 6H plus gives the reaction. So the last step is combine ions to form the compound shown in the original equation. So we know first we have written ionic form. So we can add ions. So NO3 minus only left there. So we can add hydrogen. Then we'll get NO3. Like that method we can do that. That's it. So this is our equation. 8HNO3 plus H2S gives 8NO2 plus 4H2O H2S. The next method is oxidation number method. This is a very easy method. Comparing the increase and decrease in oxidation state. So we'll see the steps. Step 1, assign oxidation to all the atoms in the equation. Step 2, identifying atom and oxidase reduce based on oxidation number. And one bracket we have to add to connect oxidation and reduce. Make the total increase oxidation equal to the total decrease in oxidation by using appropriate coefficients. Similar, like we'll see equation. Iron Fe2O3 plus CO gives iron sulfide and carbon dioxide. It's an unbalanced equation. So first assign oxidation number. We know how to assign the oxidation number. Step 2, identify atoms oxidation and reduce. If oxidation number increased, atoms are oxidized. If oxidation number decreased, atoms are reduced. And use the bracketing line to connect the atoms that undergo oxidation and another connect reduce. So this atom's carbon is undergone oxidation, iron undergone reduction. So connect arrow and make the total increase in the oxidation equal to the total decrease in the oxidation by using appropriate coefficient. So here you can see +2 change. and this is minus 3. So how can we equalize plus 2 and minus 3? If we multiply it with 3, we'll get 6. If we multiply minus 3 with minus 2, we'll get plus 6, isn't it? So for multiplying with the coefficient, we'll get like this.